everyone, welcome back to our channel. In this video, we'll study about the percentage composition, empirical formula and molecular formula. Okay, first we'll start with percentage composition. What do you mean by percentage composition and what it tells? It represents the percentage of particular element present in a given compound. Means you take water. We know that water is made up of hydrogen and oxygen. But we don't know the percentage of hydrogen and oxygen in total water volume. So that we have to calculate from this percentage composition. By using this, we can accurately calculate the percentage of the given particular elements present in that compound. Not only water, we can calculate the percentage of any element present in any of the compound, like CH4, that is methane, and ammonia. Like we have number of compounds and we can calculate the percentage of each element in that compound by using this percentage composition. This is the method how we calculate the percentage of particular element. Okay, and this percentage composition is helpful in calculating the empirical formula as well as molecular formula. Those we'll study later. First we'll see how to calculate the percentage composition. What do you mean by percentage composition? It is nothing but the percentage of particular element present in a given compound. Okay, this is the formula what we use to calculate the percentage composition. Here mass percent of an element, that is equal to mass of that element. Here it is the mass of the element present in the compound. Here we have to take, for example, water is there. Here in water, if you want to know the mass percentage composition of hydrogen, then we have to take the mass of that hydrogen here, that is divided by the molar mass of the compound. Here molar mass of the compound we have to take. Molar mass of the compound means molar mass of the water, that is multiplied to 100. Then we'll get a mass percentage of that hydrogen in total water. Okay, we'll do this by taking an example. We'll take the example of methane, that is CH4. Okay, before starting this, we'll calculate the molar mass of this CH4. Okay, how to calculate the molar mass? That is atomic mass of this carbon and atomic mass of hydrogen will give the molar mass, that is molecular mass. Okay, we have the atomic mass of carbon, that is 12, plus hydrogen. We have hydrogen atomic mass is 1, that is multiplied to 4, we'll get 4, that is 16 grams. Okay, this is the molar mass of CH4. Okay, now we'll calculate first about the carbon, means percentage composition of carbon present in CH4. This is carbons. How to calculate? First we have to take mass of the element, means mass of the carbon, that is 12 divided by molar mass of the compound, that is 16 into 100. So we'll get 75%. Okay, now we'll see hydrogen. Mass of the element, that is hydrogens. We know that mass of the hydrogen 1, but here we have 4 hydrogens. So we'll take 4 into 1 divided by 16, that is molar mass of the compound, into 100. We'll get 25%. And this is the percentage of these two are the percentage of carbon and hydrogen in CH4 molecule, or in CH4 compound. The carbon present in 75% and hydrogen is present at 25%. Means these are the percentage compositions of both hydrogen and carbons in methane compound. This is how we calculate the percentage composition. Like this we can calculate the percentage composition of many of the compounds. Okay, next we'll see the empirical formula and molecular formula. Now we'll see about empirical formula and molecular formula. We have already studied about the empirical formula in our last videos, but I'll just recall you the definition of these two. Okay, what do you mean by empirical formula? Empirical formula, it represents the simplest ratio of the different atoms present in a simplest whole number ratio of different atoms present in a molecule. But what is molecular formula? It gives the exact number of different atoms present in a molecule or a compound. For example, I'll tell you. Here we have glucose, whose molecular formula is C6H12O6. If we take the empirical formula of glucose, it will become CH2O. Means here it is not giving the exact number of atoms present in that molecule. It only tells the ratio of these atoms. Here what is the ratio? If you take the ratio here, means how to take C6H12O6 is there. So okay, here you take the 6 out, means 6 is common here. Then it will become 6H2 and O. This is how we take the empirical formula. Means this only gives the ratio at which these different atoms are present in that compound. But what is molecular formula? Molecular formula gives the exact number of different atoms present in that compound or molecule. Here this is the molecular formula and this is the empirical formula. This is the main difference between these two. And how we get the molecular formula? That is molecular formula which is equal to N into empirical formula. N into empirical formula. Here N is a whole number. To get a molecular formula, if empirical formula is multiplied to a whole number, then we'll get molecular formula. For example, you take this glucose only. Here glucose is C6H12O6. If we have only the empirical formula, that is CH2O. This is the empirical formula of glucose. Now N is 6. Means if we multiply this empirical formula with 6, then we'll get this formula only, right? 6. Then C6H12O6. This is nothing but the molecular formula of glucose only. So molecular formula is N into empirical formula. N is any of the whole number. This N need not be 6 always, because it may be 2, 1 will be not there, 2, 3, 4, like this you may have anything, but it must be a whole number. Okay, this is the relationship between molecular formula and empirical formula. Next we'll see one problem from which in which the molecular percentage masses are given, from which the empirical formula as well as molecular formula can be calculated. Okay, we'll see that problem. This is the question what they have given. Okay, in question they have mentioned the percentage composition of hydrogen, carbon and chlorine. Along with that they have given the molar mass of the compound. This is the molar mass of the final compound they have given, and they are asking us to find the empirical formula as well as molecular formula. Okay, to get the empirical formula and molecular formula, we have to follow 5 steps. Okay, we'll see those steps one by one. Now we'll start the calculation step by step. Okay, first they are given in a percentage composition. First step is we have to consider the whole compound as 100 grams. Okay, the whole compound, we don't know the compound. We have to find that molecular formula and empirical formula. But for the first step, what we have to do, we have to take it as 100 grams. Okay, if we take the whole compound as 100 grams, then these also, hydrogen also becomes 4.07 gram and carbon also becomes 24.27 gram, like what I have written here. This is the first step. First we have to take them in grams. Okay, second step, we have to calculate the moles, number of moles of the each compound. Here hydrogen, carbon and chlorines. Okay, we have to calculate the number of moles of this each element here. Okay, how to calculate the number of moles? Number of moles is equal to mass of that element divided by molar mass. Okay, this is the mass what they have given, and this is the molar mass or the atomic mass. We'll see it as atomic mass. This is the atomic mass of this element. Okay, we'll calculate the number of moles of each element. First we'll calculate hydrogens. Hydrogen mass is what they have given, that is 4.07 gram divided by what is the mass, atomic mass of hydrogen, that is 1.008. Okay, we'll end up by getting it as, it will be 4.04 only. Okay, now next we'll calculate about carbons. This is 24.27 divided by 12.011. So it will become 2.021. Okay, this is about chlorines. Okay, 71.65 divided by 35.45. Okay, this will get 2.021. These are the number of moles. Number of moles equal to mass divided by atomic mass. Here this is the mass of carbon which is given in the question only, and this is the atomic mass of the carbon. We know that atomic mass of carbon is 12. By that we'll get 2.021. These are the number of moles of each elements, hydrogen, carbon and chlorine. Now we got the moles. Next step is we have to take the smallest mole. Here we got 3 moles. This is 4.04, this is 2.021 and this is also 2.021. We have to divide these moles, we have to divide these obtained moles by the smallest number. Here in these 3 numbers, what is the smallest one? That is 2.021. So okay, we have to get that empirical ratio. Now we have to divide it by the smallest number among these 3 number of moles. If we divide this 4.04 by 2.021, this is 2.021 is the smallest one, no? So we'll get to approximately 2.01 will get, but that is very small, so we'll take it as 2 only. Here also 2.021, that is divided by 2.021 only, we'll get 1. It is also same, 2.021 divided by 2.021, that is also 1. So what we got now? We got 2, 1 and 1. These are the ratios of these elements. What we got? 2 is to 1 is to 1. These are the ratios. Now if we multiply these numbers to the corresponding elements, then we'll get empirical formula. Here what we have? 2 is to 1 is to 1, right? 2 is for what? For hydrogen. First we'll write carbon, hydrogen and chlorine. Okay, these are the elements what they have given, and now we'll multiply these what we have got the numbers, no, to those respective elements. For 2 we have got for hydrogen, so here you keep it as 2 which is multiplied to hydrogen, and for carbon we got 1. Okay, for chlorine also we have got 1, and this is the empirical formula of these elements with the percentage composition. Okay, the empirical formula is C1H2Cl, or you can simply call it as CH2Cl. This is the empirical formula. Now we got the empirical formula. Now let us see how to calculate the molecular formula. Okay, now we'll find the molecular formula. To find the molecular formula, we must know the molecular mass. By the help of molecular mass, we will calculate the molecular formula. First, we will calculate the empirical formula mass. We have got the empirical formula, that is CH2Cl. Empirical formula mass is nothing but the addition of the molecule atomic masses of these atoms present in this empirical formula. So to calculate or to know molecular formula, we must calculate this empirical formula mass. So this is carbon. This is the atomic mass of carbon, which is added to the atomic mass of hydrogen, which is added to the atomic mass of chlorine. So lastly we got 49.48 grams. This is the empirical formula mass of CH2Cl. And we know that N that is equal to, which is molar mass divided by the empirical formula mass. This is the formula. Okay. Now we have molar mass also, that is 98.96 divided by, we have empirical formula mass that we have calculated, that is 49.48. So we'll get, that is 2. Here 2 is N, and we know that empirical formula which is multiplied by any of the N will give the molecular formula. Here we got N. So simply by multiplying this N to this empirical formula, we will get molecular formula. Okay. What we have got? We have got N equal to 2, right? That is CH2Cl is there. Now if you multiply this 2 to each element, then we will get molecular formula, that is C2H4Cl2. This is the molecular formula of this compound. Okay. In question what we had only the percentage composition of the elements along with that molar mass. With that, what we have calculated? We have calculated the empirical formula also, and we have calculated the molecular formula also. Okay, this is how we calculate the empirical formula as well as molecular formula by the percentage composition and molar mass. Okay, I hope you got the clear idea about how to calculate the percentage composition, empirical formula and molecular formula. Okay, if you have any doubts, you can ask me in comment section. Okay, have a nice day. Bye.